So now we want to take the idea of prime or composite and apply it to numbers that are really big. So up here in our sieve that we just completed, we got to stop when we got to the factors of 10. That's because we have a nice rule that we check up to the square root of n. In our case, it was the square root of 100, which is 10. So I don't have to check anything larger than that. It honestly makes my life a lot easier. I don't have to check all the numbers up to 100. Checking the numbers up to 10 is way easier. So I'm going to do the same thing down here with numbers that we don't know as much. So the square root, at first I want to see if 397 is prime or composite. Well, honestly, I don't know if it's prime or composite or not, but I'm going to use this method. So I'm going to figure out what the square root of 397 is. And I've got a calculator to help me. No one expects you to know if this one has a perfect square or not. So I'm going to type this in, and my calculator is going to give me these crazy decimals, and we'll talk about what those crazy decimals mean later in another video. But it gives me something like 19.9, blah, 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 blah. So all I need to check up to 19. What I care about in this is 19. And I only have to check those prime numbers. So the only numbers I need to check are 2, 3, 5, 7, 11, and 13. So I'm just going to see if 397 is a factor or is divisible by any of these numbers. Well, I know it's not divisible by 2 because it's an odd number. So that one doesn't work. I'm going to type 397 divided by 3 in my calculator. That one doesn't work. I know 5's not going to work because it ends in a 7, so it can't work. 7 I'm going to try. 397 divided by 7. Nope, it doesn't work. I'm going to keep going. 397 divided by 11. Nope. And neither does 13. So none of these numbers divide 397. That means that none of these numbers are factors. So therefore, it is prime. If one of them had divided it, it would have been a factor. So 397 would have been composite. So this is how we find prime numbers. There's no formula, there's no magic touch to this. That we really just have to do trial and error. This is how mathematicians determine if a number is prime or composite. There's no faster way. So I'm going to let you try the next example, 91. Stop the video, give it a try, and then after you have your answer, if you think it's prime or composite, then you can start it back. Just remember, I need you to show work on this. I need to see this square root and which numbers you tested. You don't have to write down what the answer is, but you do need to show me which numbers you tested. All right, so let's see if your work matches mine. So I'm going to type in the square root of 91 in my calculator. That gave me 9 point something. 9 dot dot dot. We'll talk about the decimals later on. But right now, all I care about is this number. So I need to check all the prime numbers up to 9. So I'm going to check 2, 3, 5, and 7. That's all I have to check. 9's not prime, so I don't need to check it. I don't need to check 11 because it's bigger. Well, I know 2's not going to work because 91's odd. If I type 3 in my calculator, 91 divided by 3 isn't an even number. I know 5's not going to work because 91 doesn't end in a 5 or a 0. So my last number to check is 7. And I type that in my calculator and I do get that 7's a factor. 91 divided by 7 is 13. So this one does work. Since it does, 91 is a composite number.